This problem deals with absolute convergence. Now, if you remember the rule for absolute convergence, it says that absolute convergence implies convergence. In other words, if a series converges absolutely, then it converges. Let's take a look at an example of this. Here's a question like what you might see on your final exam. We are asked, does the series converge or diverge? Does the series converge or diverge? Now, at first, there are some interesting things happening here. First of all, n starts at 2. It doesn't start at 1 or 0, and it kind of makes sense why it would not start at 0, because if this were 0, well then you would see right away that it would diverge, because anything divided by 0 is just infinity. So by the very first term it would be divergent. So we're starting at 2. Next thing is we have cosine of our integer n here. And that's kind of interesting because this thing is just going to oscillate between 1 and -1, and it's not going to be every other time that it's going to be positive or negative. Sometimes it's going to be 1, sometimes it's going to be negative, sometimes it's going to be positive, sometimes it's going to be negative. It might be positive a couple of times, and then it might be negative a few times in a row. It's not going to be as evenly spaced out as if we just had, -1 to the nth power or something neat like that. And then we have that over n squared, and you know that if this looks a little bit familiar as a p-series, because if we had just the series of 1 over n squared, no matter where we started, well, not 0, but from 1 onward, you know that it would be convergent if we just had a 1 here instead of the cosine n. So let's see what happens if we test for absolute convergence. And we can test by putting everything in absolute value. Now we don't have to put the denominator in absolute value because it's a squared term, and we know that that's going to be positive anyway. So let's take a look at what happens when we put our numerator here in terms of absolute value. Well, that's interesting. You can see right away that now instead of oscillating between 1 and -1, it's just going to oscillate somewhere between 1 and 0. So in other words, this series is going to be less. It's going to be less than a known series that we know to converge. And because we know that this p-series here converges and it's bigger than this one, then just by our direct comparison test, we know that this one must also converge. So we could write the series converges absolutely. Via the, we could call it direct comparison test, or DCT for short. DCT, which stands for direct comparison test. And we're done. We weren't asked to evaluate this to figure out what it equaled. We were just asked if it converged or diverged, and we've just proven that it does converge.